Guys, today I just want to take a few minutes and talk about this activity, this quadrant here, and just kind of give you more guidance on what exactly you need to do. So for each of these they're really fractions. You've got the numerator, they're unit fractions. And unit fractions are fractions with a 1 in the numerator. So we've got 1/2, right? So if the numerator is 1 and the denominator is 2, you have 1/2. So to turn that fraction into a decimal, what you do is you take your numerator, which is 1, and divide it by your denominator, which is 2. And you'll see there's a problem here, right? 2 cannot go into 1, but that's okay. We know that that means we add a decimal and a 0. And I'm going to take that decimal and move it right up. So 2 can't go into 1, but it can go into 10 5 times. 5 times 2 is 10, and that gives me a remainder of 0. So here is my decimal equivalent for 1/2. Now, because I got a remainder of 0, we would call this a terminating decimal. So it stops, okay? Since this decimal does not repeat, I can't put an answer here because if your decimal repeats, this is where you're going to write the digit that repeats. Now, when I get to 1/3, I'm going to divide 1 by 3, because remember, if my numerator is 1 and my denominator is 3, I'm going to put my numerator inside, my denominator outside, add a decimal and a 0, and bring that decimal straight up. So 3 can't go into 1. It can go into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. Add a 0, bring it down. Oh, look, I just did this. I am going to get a repeating decimal. Every time I can do this problem forever and ever and ever, I'm going to keep getting 3. So you can write it with the little repeating bar above it, okay? Or like this, with the dot, 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 which means it's going to be 3 forever. So you could either do this, that's acceptable, with the line above it, or 0.3, dot, 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 dot. So since I'll never get a 0, I'm always going to get a remainder. It's not going to terminate. This would be a repeating decimal, okay? And what repeats is the 3. There's going to be a 3, 3, 3, 3, 3, 3, 3, 3, 3. It's going to go on forever and ever, okay? So that's what you're going to do for the first part, filling in this whole table, finding your decimal equivalent. Now, some of these you might know. You might already know what 1/4 is as a decimal. Okay, if that's the case, don't worry about doing all of the work, but you might not know what 1/6 is. Okay, so you're going to need to show work for that. I'm going to expect that you don't know at least 3 of these. Now, I promise also, all of these will terminate or repeat, even 1/7, but you might have to work it out a little more. Okay, it is a repeating decimal, but it's going to go on for a long time. Now, the next portion of this assignment is to go down to number 1 here. And I know we haven't talked about this yet, but this is a 5th grade skill that you should know. After you've done all this work, some repeat, some terminate. So now the goal is to determine, how do I know from looking at a fraction, a unit fraction, or really this is going to apply to any fraction with those denominators, how do I know if I'm going to have a repeating or terminating decimal? Well, number 1 is one way to help you out, okay? It's a hint. What I want you to do is find the prime factorization for each denominator. So that means we are looking down this column here, and we are going to do the prime factorization for each of the denominators in this table. Now, remember, prime factorization is where you write all the prime numbers that I multiply to get whatever the denominator is. So for example, numbers like 2, 3, 5 that are prime, they won't have a prime factorization other than themselves. So the prime factorization for 2 is 2. The prime factorization for 3 is 3. But when you get to 4, remember doing these factor trees? 4 is 2 times 2. Since 2 is prime, I can circle them. So the prime factorization for 4 is 2 times 2. So if it's not a prime number, it will have a multiplication problem for its prime factorization. 5 is going to be prime, so that one will stay. But 6 is actually 2 times 3, right? And 2 and 3 are prime. So for 6, your prime factorization is 2 times 3. So I did the first few with you, and you're going to do the rest on your own. And I want to see this in your composition book, okay? Doing this is going to help you when you get down to answering numbers. Well, you can't answer number 1 without doing it, but it's also going to help you answer numbers 2 and 3. And to help you out even further, I'm going to put the prime factors up to 100 on the screen for you in just a second here. And you can use that, so I would suggest that you pause the video and use that to help you out to find the prime number, or to help you with your prime factorization, okay? So here we go. This is the list of prime numbers, 1 to 100. You could pause the video here and just have the screen up as you're going through so you don't do work that you don't need to do. All right, let me know if you need any help, and we'll talk soon.